Welcome. Let's see technology's comparison of overhead transmission lines, gas-insulated lines and underground cables. Fundamentals of the technologies have been explained, in such a manner that it could be understood by a non-technical person or a person not involved on a day-to-day basis in this industry. Before we discuss technology's comparison of overhead transmission lines, gas-insulated lines and underground cables, let's see basics of overhead transmission lines, gas-insulated lines and underground cables. The three conductors may be assembled in an overhead line circuit, an underground cable circuit or a gas-insulated lines circuit. One basic technical aspect to be considered is related to routing a transmission line, including route availability. It must be possible to construct the line. Urbanization, if the line is to be routed through an urban area, then future developments may have an impact on the route and design of the line. Route topography, if the terrain is very uneven or hilly, the technical challenges and costs increase. Line structure. An overhead line circuit is typically composed of lattice steel towers, which support the three conductors that make up the circuit. In some lines, tubular poles, pylons, are used instead of lattice structures. Insulator. The conductors are insulated from the structures by means of insulators, which are made of toughened glass, porcelain, or of composite materials. Many OHL designs are fitted with one or several earth wires at the top of the tower. These earth wires have two functions: firstly to protect the conductors from a lightning strike, which might cause an outage, and secondly in the event of a fault, the fault current will be mainly contained within the conductor or earth wire loop, and returned to earth. It should be noted that in many cases OHL have two electric circuits, or more on the same tower. Each circuit may have 1 to 4 conductors in a bundle for each phase, and even more at ultra-high voltage lines. These OHL can carry many times the power of a single circuit line, with single conductors. The design of an OHL depends on many factors including conductor size, ground clearance, impact of weather, electrostatic or charging effects, magnetic effects. An underground cable circuit is composed of 3 power cables, 3 phases, and normally 1 communication cable installed in the ground, to form 1 electric circuit. A typical design of a power cable is shown in figure. If the power to be transmitted is beyond the capability of one circuit, more parallel cable circuits, or more cables per phase, must be installed. The larger the conductor, the more current it can carry, and the thicker the insulation, the more voltage it can withstand. The cables are typically installed in one of the following arrangements: directly in the ground, trench. In ducts installed in the ground. In concrete troughs. In a tunnel. In a pipe or pipes drilled into the ground, to pass under some obstacle. On a cable tray attached to a bridge. The design of an underground cable circuit depends on many factors including conductor size, soil thermal conductivity, presence and possible impact of other surfaces in the soil, which may conflict with the cable route either now or in the future, for example other cables, heating or cooling pipes, water supply, and wastewater. Urbanization. Possibility of flooding. Cable pulling. Electrostatic effects. Magnetic effects. GIL are generally composed of 3 parallel aluminium tubes, for one 3-phase circuit. The aluminium tubes are in sections, typically 12 to 18 meter long and 500 mm enclosure diameter. They are bolted together with flanges, sealed with O-rings, or welded together on site to be gas-tight. Automated welding process including 100% weld quality control by ultrasonic test. Inside each enclosure pipe a smaller cylindrical aluminium conductor pipe is supported by Cast resin post insulators. The GIL enclosure pipe is filled with a gas mixture of 20% sulfur hexafluoride, SF6, and 80% nitrogen at 0.8 MPa pressure to reduce the greenhouse impact from SF6. GIL may have approximately the same transmission capacity as an overhead line and about double the capacity of a XLPE cable system, depending on actual situations. GIL systems are mostly used to EHV voltages, greater than 245 kV, up to 1200 kV. GIL installation is adapted to pipeline laying technologies, and is carried out at local assembly and installation on site. GIL are typically installed above ground, in tunnels or in underground galleries. Direct buried installations are uncommon today, as it requires additional coatings for passive corrosion protection and cathode corrosion. Experiences with GIL worldwide is constantly increasing with ever larger project sizes, higher rated voltages, mainly 400 kV, 500 kV, and 1200 kV, and current ratings, 3000 ampere, 4000 ampere, and 5000 ampere. The design of a GIL circuit depends on many special factors including black small square presence and possible impact of other services, which may conflict with the GIL route either now or in the future, for example, cables, heating or cooling pipes, water supply, and wastewater. Black small square route considerations. The given bending radius can be a limiting factor for a route. Black small square urbanization. If the line is to be routed through an urban area, future building or road development may impact on the circuit. That's why separate tunnels for electric transmission lines may be the best solution. Black small square electromagnetic effects. GIL circuits have negligible electromagnetic effects, as the electric field is earthed through the metallic enclosure. The magnetic field is mostly superposed by the induced current into the solid grounded enclosure pipe. Investment costs of overhead transmission lines is not so high compared to gas-insulated lines and underground cables. Gas-insulated lines and underground cables cost is high compared to overhead transmission lines. This comparison refers to transmission lines exceeding 220 kV alternating current. Direct current connections and subsea cables are not a part of this comparison. There is no much installation difficulty of overhead transmission lines, compared to gas-insulated lines and underground cables. Installation difficulty is more in case of gas-insulated lines and underground cables. Overhead transmission lines, gas-insulated lines and underground cables continue to evolve with improvements in the manufacturing and in the installation equipment and technologies. Overhead transmission lines, gas-insulated lines and underground cables could have competitive tendering based on techno-economical feasible solution. GIL may competitive tendering in some cases with short length. All technologies, i.e. overhead transmission lines, gas-insulated lines and underground cables, are reliable. Repair time is high for GIL and underground cables, however it is highly dependent on the availability of spare parts, and thus on maintenance policy. While overhead transmission lines required less repair time. Life expectancy in case of overhead transmission lines is greater than 80 years, for gas-insulated lines greater than 50 years and underground cables, it is greater than 40 years. Overhead transmission lines installation is faster than underground cables or GIL, while installation time for gas-insulated lines and underground cables depends on local site conditions and requirements. Now let's see conclusion. It is very difficult to compare the three technologies, as each installation is different with respect to location, importance of the circuit, costs, reputational and financial impact, if there is an outage, method of installation, operational and maintenance aspects, environmental impact, planning or licensing, lifetime, etc. In view of this, no general conclusions can be drawn, and each installation must be treated on a case-by-case basis. Project engineer will not wish to propose an installation that would be unacceptable to the planners or to proceed with a development that may appear too costly, or where the technology is not suitable for the proposed end use. Thank you for your attention and time. More stuff coming soon. Don't forget to subscribe.